He's the director of consulting for Level 11. DevOps is his specialty and focus. Our goal, I hope with him, is to continue to fill that skills gap by teaching kids the skills of the DevOps community, which people want. And I think it ties into multi-cloud in a unique way. We're going to learn and figure out exactly what that is. So we just really appreciate Level 11 and Synapse letting us come here to their awesome house, and let Benson take it from here.
Good. Am I on? I've been told that I shouldn't project too much with these mics or else I'll hurt people. Anyway, thank you, Jason. I'm Benson Miller. I work here at Level 11, focused on DevOps and automation. I want to just reemphasize the thank you to Synapse. We've been partners with Synapse product development for about 5 years. They do really remarkable things in the wearable devices, bespoke product development for a lot of consumer wearables and things. If you're interested in that, interested in the Internet of Things, you should find a Synapster. There are a few here that I see, and ask them questions about that. But thank you very much, Synapse, for letting us share your space for 5 years and use this space. So, with that said, I know you came here for these three gentlemen sitting to my left, and I'd like to start just with allowing them to introduce themselves.
I'm Tim Connor. Can you hear it? Okay, so. Sound? Nope.
Keep talking.
My power's on. Okay, yeah, sorry. Testing, 1, 2, 3. On now. Okay.
There we go.
Mike, how do I put this down? All right, you can still hear me? Or, no? Yes. Stick mic. Hello? Does this work now? Okay, a little better. Let's try this again with no projecting. Tim Connor, President of Cloud City Development. We are wholehearted software development and design that betters our world. If you need any help building or scaling up, designing, getting your product shipped, we can help.
Hi, I'm Randy Bias. I'm the CEO and founder of Cloud Scaling. We're a company that makes open source software so people can build their own Amazon Web Services behind the firewall. I'm a prolific blogger and writer on the topic of cloud. And the first cloud company I worked on was in December of 2006 when I built an orchestration engine around Puppet so that people could deploy into-tier web applications on Amazon Web Services EC2, which at that time was in private beta. And then prior to that, I've got 20 plus years of doing infrastructure, networking, storage, information security, automation, the whole ball of wax.
Hi, I'm Jesse Proudman. Can you hear me? Yes. Oh, don't project. There it is. Look at that. This is a great example of cloud right here. You get three same mics, and none of them work the same. So I'm founder and CTO of a company called Blue Box Group here in Seattle. Founded the company 11 years ago. So we built the first, or a first container cloud in 2007 before containers were cool. Today we're delivering private cloud as a service powered by OpenStack. So each customer gets their own single-tenant OpenStack installation where we manage and operate the cloud itself, and the customer gets to experience the benefits of private cloud without the pain.
Good. Well, thank you all for coming. I'm really excited for this discussion. I think the best place to start is acknowledging that this is both a cloud and DevOps discussion, and the primacy of which is sort of irrelevant. They're completely entangled. And so I'd like to start with some brief definitions up front. So maybe Tim, can you lead off and give us a brief definition of DevOps? What is this DevOps movement, and why is it important for today's business?
So DevOps is simply the merging of Dev and Ops, like the name says. It's empowering your developers to more simply ship their software. Much like all the rest of these terms, it's not really a thing. It's a whole series of things that had already been happening that someone's like, oh, hey, let's slap a name on this so we can better talk about it.
Some of the later questions about ops versus development, there are plenty who argue if you are talking about those two separate things, you're not actually doing DevOps. So it is a definition that's up in the air of whether it means just continuous development, more easily enabling anyone on the dev team to deploy and manage their own software, or it means entirely merging them so the dev team is responsible for the full operation of their software. Where that line goes varies by organization and by who you ask. But in general, it's simply what it sounds like. The merging of development and ops in the modern world, which has a lot to do with the cloud, of why it started to become a thing where any single developer in a day could push up an entirely new stack. So now what do they need to know to do that right within your organizational concerns?
Good.
So I'm probably not going to give a definition because I think those can be a little bit overdone. I'm going to tell a couple of stories. So in fall of 2009, when I was starting cloud scaling, we were doing consulting for a number of companies, and one of them is this small healthcare provider called Kaiser Permanente. Kaiser was in the throes of trying to figure out their private cloud strategy, and at one point, they went dark for 2 to 3 weeks. The entire IT leadership team just disappeared. And when they got back, I said, what happened? Where did you go? And they basically said, well, we had 3 site outages at kp.org in 1 month's time, and we had to go sort of deal with that. And the fundamental problem there was that kp.org was being run in the traditional enterprise manner, which is you had the storage guys, you had the server guys, you had the network guys, and nobody had complete responsibility for site uptime. And that was a huge problem. kp.org is a cornerstone of Kaiser's business. And when we engage with enterprises today, one of the things that I always see is this horrible disconnect between the line of business and the application developers and the IT and operators and infrastructure staff. These guys over here are doing everything they can to run fast and make the business be more successful, to bring new applications to market, new initiatives. These guys are over here just trying to manage down risk. And what winds up happening is that you've got this dysfunctional relationship. You get the application developers, the line of business, go to the infrastructure guys and say, look, we need this new infrastructure for our app. Here's our list of requirements. It's huge. The infrastructure guys come back and say, well, we can do that, but it's $10 million in 18 months. And the problem is that the line of business guys don't care about that. So they go to Amazon Web Services and they get this much of their wish list, but they get to go immediately. Because the reality of the situation is that we're moving into a world where the speed of the enterprise matters more than anything else. According to one of the Forrester analysts that I love to quote, Craig Leclerc, he said, over the last 10 years, 70% of the Fortune 1000 has been turned over because of their inability to adapt to change. Adapting to change is now a absolute critical existential question for enterprises of all sizes, and DevOps, I think, is the cornerstone of enabling that. It's really about breaking down the barrier between the line of business and the application developers and the infrastructure folks so that both teams can be successful. And there are examples of this in the wild, like Fidelity, and I'd be happy to talk about that later, but I don't want to bogart the mic.
And Jesse, if you could continue in that vein, but also if you would take the opportunity to help us all understand a little bit better these terms, private cloud, hybrid cloud, multi-cloud, and sort of what the major trends are that are shaping the environment.
Absolutely. So yes and yes. I think let's start with definitions. We'll come back to DevOps. So public cloud is a massively shared set of infrastructure, typically centered in very large hyperscale data centers where a single vendor provides a set of APIs to deliver a service catalog, meaning compute, networking, storage, database, caching, queuing, list goes on and on and on. I think Amazon has 124 services now, or plus. Every week they release more from those hyperscale facilities. Private cloud historically has meant a piece of software that is installed on equipment I purchase and put in my own data center that mimics much of the API compatibility of a public cloud. But today now means an environment where I am the only tenant as a customer of that installation. So no other end user can sit on the physical hardware that my infrastructure is running on outside of whom I've given access to. Multi-cloud means a combination of multiple public cloud providers or private cloud providers used in conjunction to deliver an application. So we're beginning to enter this world where cloud has really changed its definition. It's no longer just about consuming a externally hosted service. It's no longer about an on-premise environment. It's about how you actually deliver and consume services. As Randy began to touch on, it's around how do you speed up delivery of applications to the end user. And it's about how do you start to consume services from a service catalog instead of consuming VMs where you operate them as you traditionally, as IT has traditionally done. So DevOps plays a role in that, much like these microphones, right? Now you've got this service catalog, and you've got API calls where things are delivered inconsistently from provider to provider. So to me, DevOps is really about the practice of, as an enterprise engineering group, how do I begin to architect my applications and architect my approaches to cloud infrastructure in a way that builds compatibility against wherever I go.
So one of the things I heard there, and one of the questions that we have is, cloud's this enormously powerful tool, but we all know you can't just stand up a cloud and the next day see these enormous revolutionary gains in quality metrics or feature velocity within your team. So what are the co-requisites and really the critical factors for organizations to get the most value out of any cloud investment that they make, whether it's public or private?
DevOps is part of it, a culture of innovation. If you're saying you have a cloud initiative, I think you're 75% of the way to being started wrong already, because you're focusing on the what you're doing, which is, hey, let's build a cloud, not the things we've been talking about, which is how do you enable your developers to push an app out more quickly. That can be private cloud, that can be hybrid, and more securely in whatever your organizational requirements are. But a culture of monitoring and DevOps and de-siloing between these departments and all of these things that have all come together in these movements to be called things like DevOps, that you can't just tack on, but you need to really work on your process. You can hire people with experience to come in and consult on this process and help you build for it, but it's a fairly holistic thing. If you say, oh, we have a cloud initiative, we'll just build a cloud and then we'll be caught up and we'll be able to just deliver products, you're missing a whole lot of prerequisites around your developer and your ops culture all the way through its core.
So Randy, you must get customers coming to you and Jesse saying, we need a cloud. And I'm sure it doesn't present itself that simplistically, but how do you engage customers that have cloud initiatives to try to make sure that it's as successful as it can be?
Well, so the number one challenge that people always have after we get a system up for them is adoption. People, the very first cloud we built was as a business, not prior to forming the business, but as a business was for Korea Telecom, and we got it up and they had no idea what to do with it. I mean, they were literally, stunned. They wanted to bring over things like Oracle databases, and I was like, okay, look, we got to go back and talk about this again. So that's the number one problem, and what it leads to that challenge of adoption is cultural, and it's about cultural shift. It's about a mind shift change. I talked about Fidelity before, and what I found really intriguing about Fidelity is they basically took that sort of dysfunctional contract between application developers and infrastructure and infrastructure teams, and they rewrote it. They said, okay, you application developers, you can use and consume as much of these private clouds we've just built you as you want without, any training wheels. It's all on your own. But in order to do that, you have to jump through these hoops. Every application has to be deployable with Puppet. You've got to deploy it onto QA, then staging, then production. You've got to have some way to basically show us that you're doing continuous deployment, continuous integration. And they set up all these gates. And then they made sure that they're mixing in all the security recipes that they wanted and all that good stuff. And by doing that, they rewrote that contract so that the infrastructure team was able to manage down risk like they wanted to, and the application development teams were able to go as fast as they want. And so I think we're just entering into an era where the core disruption is around the culture within the business, right? If you are the IT guy who manages the Microsoft Exchange platform, your job is done. That job is over, right? On the other hand, there's all these lovely new opportunities to level your business up, to help it be more successful, to move towards DevOps, to start thinking about ways to actually increase the velocity of your business. And I think those are the two worlds we're starting to see. And if you'll just permit me 1 second, my very first job when I was 19 was at this wafer fab test company in the Valley. And when I walked in there, I was 19, and all the other systems administration guys basically were clock punchers. They came in at 9 o'clock and they left at 5 o'clock, and they did everything manually. I automated the living crap out of that system, and they were pissed. They were so pissed at me. But I was the senior guy a year and a half later, and I was basically managing 300 servers pretty much single-handedly at that point, and had put all the rest of the guys out of a job. That's where we're at. That's what's changing right now. And the only way to create success is to create a path for people who are currently going to have their jobs disrupted to be the heroes.
Absolutely. So we call that the we have a cloud, now what problem. And we see this all the time. If people come in and they say, look, we want a private cloud. We need a cloud strategy. My board of directors and C-suite are pressuring me to do something here. And we can get them up and running very quickly. And then once they're up and running, they have no idea what to do with it. And I think, again, it's what everybody here is saying. It's a cultural challenge. How do you change the thought process that goes through those folks who are consuming resources to go beyond thinking about things as single VMs and really think about changing the architecture of applications to utilize that service catalog that's available to them now?
So Randy, you mentioned sort of your disgust or horror at the prospect of shifting traditional Oracle RDBMSs up into the cloud.
Mm-hmm.
Enterprises have these decades-long investments in non-cloud native applications, traditional enterprise systems, what you might call IT archaeology. How should enterprises look at that investment in the face of both cloud and DevOps investments towards agility?
What's funny is I always look at like Amazon and Google and Microsoft and to some degree Apple, and these are businesses that as they get larger, they go faster, right? The traditional enterprise gets bigger and goes slower, right? And the reason is that it's just a complete rethink about how to do things. And when I think about, how I tried to describe this to people in the past, I use this pets versus cattle analogy, which maybe some of you heard about, which is sort of like, you can treat your servers like pets or you can treat them like cattle. And when they're pets, they're all precious. It's Bob the mail server. And if he gets sick, it's all hands on deck to nurse him back to health, get Bob back up. Whereas, in the cattle way of looking at servers, that they're all numbered, and if one of the cattle gets sick, you take it out back and you shoot it and you replace it with another one. And that disposability of servers, that way of thinking about the world, that's inherent in the way that people like Google build their infrastructure. And the legacy way really brings a lot of burdens. I was talking to Oracle at a very senior level recently, and we were having a conversation about, kind of the way that they thought about the world. And I said, is there any chance that the Oracle rack guys will get rid of the requirement for a quorum disk drive where all of the rack servers basically write to? And they said there's no chance. Right? Now it's crazy to have a distributed database all write to a single point of failure disk drive to negotiate which one is the master, right? That just, it sort of boggles the mind, right? It's a hardware requirement driven by software, where we're moving into the world where the software wants to deal with an abstraction, as Jesse said, that sort of like, removes and hides all the underlying complexity. And you just have to get in that mentality of we're building cattle clouds, we're building, cloud native applications. We're not, going to bring the legacy with us.
So I want to jump on that. So you said sort of archaeological exploration of enterprise applications, and I think that's a great way to describe it. So you don't build a building to last for 200 years. You build a building to last for 50 years, right? And what we're starting to see, we've got a media company, top 3 media company. They've got, and these numbers are a little fuzzy, but 340 line of business applications. They're things written all the way from COBOL to whatever. They said, look, we're not going to be able to lift and shift these from what we're running today into a cloud architecture. We need to approach everything that we're doing differently. What they've done is begun a big initiative internally to build both a cloud architecture based on private cloud and platform as a service, and then an engineering team that can write applications on top of that architecture. And they're slowly methodically going through all of his applications one by one, figuring out which one they actually need, which ones they can kill, and which ones they can rebuild to run on a cloud architecture, and they're rewriting it. So the last meeting we had about 2 weeks ago, they said, look, we're going to go from 340 to about 120 applications. We're going to rewrite all of them. They've got about 12 completed today. It's been a 2-year initiative. Those 12 included all of the framework tooling that they needed to actually build them for a cloud-native architecture. And now they can go through the rest of their architecture teams and engineering teams and rebuild the rest of them. You're never going to see an environment where legacy IT infrastructure is lift and shifted from traditional deployments into cloud. It just doesn't make sense, and it doesn't work, and nobody's satisfied with the results. But what you will see, and this is one of the powers, I think, of private clouds, are the ability to deploy infrastructure adjacent to legacy deployments and begin to do those rewrites, still connecting back into data sources. So this company still has an SAP installation. They're not going to get rid of that today. They may get rid of that in 3 to 5 years, but they're able to tie all these new applications back into that data source based on that private cloud implementation. That's the path I think we need to see, and that we'll begin to see more of over the next couple of years.
And there's a problem, though, when you build houses for 50 years. We currently have crumbling infrastructure throughout the suburbs here, and that is a great corollary to the state of a lot of the enterprise software. They should talk to their CFO about what sunk cost means and what sinking more cost after more sunk cost means and what that'll do to your business. At the end of the day, they do have to move forward and face far more irrelevancy if they don't. But I think what you said about some of the smaller rewrites are important. I don't know how many large rewrites I've seen be horrible ideas that any of us that have consulted for a long time caution people, do not rewrite your whole system. Don't pull a Netscape. Don't spend the next 3 to 5 years rebuilding all of the systems at once. This sort of move to cloud goes along very nicely with a move to SOA and other systems where it's not just at each server level, it's across all your services and everything. You need to rebuild your whole teams and your culture. So keep everything you have because it's running and start slicing things out. Make the new division that's cool and hip and does this section. And it will be a long, ongoing process because you need running software at every point of the way. So I think a lot of these movements go hand in hand. SOA, DevOps, cloud, and all of them, if you do them right, and bake them into your culture, allow you to continue succeeding at every step of the way. You always need working software. Otherwise, what's the whole point of it anyways?
And I want to tie that back to multi-cloud architecture. I think one of the challenges with public clouds is, again, they exist in these massive hyperscale data centers, and sure, Amazon has 13 of those geos around the globe, and that's great. In certain areas like Ashburn, Virginia, you can be within sub-millisecond latency of an Amazon POP. That's wonderful, but there are plenty of on-premise existing data centers with the Fortune 1000 enterprise that don't sit there, or with middle market enterprise that aren't within realistic latency of a hyperscale data center. And so private cloud opens up the possibility for these enterprise companies to have that service catalog of delivery, but have it within proximity to the actual existing implementation. It's that proximity and that latency differential that will actually open up the potential of beginning to rewrite portions of applications, because applications need to talk to where the data resides, and that data resides on premise today. So that's the transformation that's happening right now that I think really fundamentally changed the way applications are developed.
So one of the things that I want to respond to is this investment in planning and application refresh. It can take a lot of effort. And when we talk about adopting cloud, especially private cloud, I think you're talking about enterprises they're getting these benefits of these incredibly powerful, easy to use, developer-centric APIs. But there's a cost to be paid for those, in that cloud architectures are not simple to maintain necessarily. The failure scenarios can be very complicated. And so in the context of getting rid of the old type of complexity, you have this heterogeneity, you have the IT archaeology, as I called it. Are you shifting it for a new type of complexity in the cloud distributed system sort of complexity? And how should enterprises think about this trade-off?
Well, what was interesting when we went into Create Telecom is I walked in and we started having this conversation about what kind of cloud they needed, and they said, we need a 5.9 cloud. And I said, you need a 5.9 cloud. Okay, I can build that. Do you know how expensive that's going to be? Well, we have apps that require 5.9s. And I said, okay, great. Tell me about an application that you have that requires 5.9s. Well, our billing system. We're a carrier. They can never be down. We need a 5.9 infrastructure to put underneath it. I said, great. What was the uptime of your billing system last year? 3 nines. Year before, 3 nines. Year before, 3 nines. I said, well, we can put a 5.9 infrastructure underneath that, but it's still going to be a 3.9 app. And the reality is that the complexity is shifting out of the infrastructure into the application. But if we want 3, 4, 5.9 applications, that's the only place it can go. That's the only place it can go. This is the hardest problem that I have trying to communicate to existing enterprise folks. They're used to trying to take this risk mitigation approach where it's like, if we just throw everything in the kitchen sink at it, we gold plate like all the hardware. We have, triple redundancy on everything. It'll never go down. And the reality is
until
that
somebody hits the EPO.
Yeah, and then it still happens. And the thing is that when you shift the responsibility to the app layer, it does become more complex, but it means that you can do a lot more. You can do, dual transactions across 2 data centers that are, 2,500 miles apart, and the latency doesn't matter because you're figuring out how to do those transactions in a way that works for your business. But that shift is actually important, and it's fundamental to our success. And if we want to move to a world where we have all these online services that have very high uptimes, we have to accept it.
Yeah, I think one of the biggest challenges today, if you look at public cloud architectures, there are, like Netflix is a classic example. They say, look, we architect around Amazon's weaknesses. Great. Then you look at companies that say, we're going to go deploy private cloud on-premise. And the reality is that the benefits of cloud mean outsource infrastructure, they mean outsource operations of that infrastructure, and you're really using the services that are available on top. Well, the IT teams that are used to running VMware or running things on-premise don't necessarily know how to deal with the failure scenarios that exist within a private cloud itself. So Amazon, you get the application architecture to talk and to survive against those failure scenarios. Yet on private cloud, you have an environment where the failure scenario could be the entire cloud in itself. So I think we've got this interesting challenge of duality of environment, and people tend to say, look, I want private cloud because it exists. I'm used to it, right? I can put it on my hardware, I can touch it, I can have Bob the VM server sit there, and I can fix it when it breaks. But the scope of failure has increased so much more dramatically with that type of deployment that people, it just boggles their mind when they think about how to solve these things. And I think this is one of the challenges we've experienced today with, particularly with OpenStack, as we talk about people adopting the technology and then giving up because it was too hard. It's because the way OpenStack has been delivered today requires such a level of expertise inside of an organization that things break and they just give up on it. As Randy was saying, look, we need it to be up all the time. Well, you need the experience on how to run these things. You need the technology to be distributed and delivered with not just support, but with that actual operational capability. And we've just been approaching it. The industry's been approaching it all wrong to date. Public cloud's got it figured out, but the private cloud marketplace, which really gives that enterprise the power, again, because of that proximity, has had it all wrong for the last couple of years.
Do you remember the giant AWS downtime a couple, 2-3 years back?
Which
There
one?
were 2 of them.
Was it the multi-day, like the biggest
They had
of
the
them one?
EBS control plane flood,
Yeah.
and then they had a second EBS failure due
Yeah,
to
the
And then the
power
ELB
outage
one
and
on
lightning
New Year's
strike.
Eve
Where-
or Christmas
The
Eve.
first
That was
one where it
the
first came
second
out,
one.
that people were just spinning through instances and it sort of cascaded worse.
Yeah, that was the
Yeah.
EBS control plane
Yeah, that one.
overflow.
One of our advertising clients was up the whole time due to multi-zone.
Netflix was up the whole
yeah,
time.
exactly. It is
Except for New
possible.
Year's, Christmas Eve.
Yeah, that one they didn't
It
do
is
well.
possible to stay up
That was
through
their fault.
those. On the other hand, you remember when the Media Temple building lost power? They had the cascading failure, all the redundant backups in the world. They lost power. The backup generator kicked in, put too much strain on the backup generator, which kicked out. And everyone in the Media Temple building lost all of their web for I don't remember how long. You are approaching a point where public cloud might have its problems, but if you build right for it, is going to be better uptime than you're going to get on your private hosting. And unless you are very competent at what you're doing, you have multiple data centers that can rival Amazon, and that you can build systems that on public cloud or more robust if you handle this. So at the end of the day, it comes down to a why do you really need private cloud? Unless if you're scared of this complexity, maybe you shouldn't be building and maintaining a private cloud. If you don't have the distributed systems team on hand to debug these sort of hard problems, is public cloud such a bad thing?
I don't see these things as separate
Yeah, I
things,
don't
actually.
agree.
I mean, in my experience, everybody's looking at hybrid cloud. They're not looking at private and public. They're looking at both.
Multi-cloud.
Fine, call it what you like. I don't care. And the reason is that, one, distribution of risk, but two, it goes back to my definition of cloud, which has nothing to do with outsourcing. My definition of cloud is that cloud computing is a new form of IT that's coming from the web scale guys. If you go and you look at what Microsoft and Amazon and Google all do in their data centers, from the concrete through the applications themselves, it is fundamentally different than anything that's been done in enterprise data centers ever before. At the same time, all the patterns they're using are highly overlapping. If you drew a Venn diagram, you'd almost have a circle, right? So that's cloud computing. It's this new way of doing computing that displaces what I think of as enterprise computing or client server in the same way that displaced mainframe. And so the example I like to give is Hadoop. I fit big data and DevOps inside of cloud. That's me. When you think about Hadoop, what is Hadoop? It's Google's MapReduce. Except it's not just Google's MapReduce. It's Google's MapReduce plus Google's reference architecture. It says use commodity hardware, use commodity rack mount servers connected with a reasonably high-speed switch fabric, use a JBOD with no RAID, and scale it out and use Linux. Now, if you went back 10 years and you told companies they'd be doing business intelligence on top of a scaled-out Linux system using commodity components and no redundancy at the data layer, they would go, "You're crazy." But yet, it's taken off in a huge way. It's because those techniques are bleeding down into the mainstream now. So you don't have a private cloud if you've got a VMware system. You don't have a private cloud unless you've built a private cloud that looks like Amazon Web Services, that brings the same kinds of cost efficiencies, that has the same guarantees around VM uptime, 2.5 nines. And unless you're writing your cloud native applications on top of it and getting the 3, 4, 5 nines by doing that. And if you're doing all that, you should, of course, be taking those applications and building them in a deployable framework that allows you to do repeatability both on your private cloud and your public cloud and move those applications back and forth as needed.
I also think some of the complexity is misstated in that every computing system is distributed. And before the cloud, people pretended they weren't. They pretended, oh, we're not building distributed systems. We're just doing simple database replication. Sorry, simple database replication is a distributed system, and it had the same problems. Now that we have more latency, we start seeing the real problems that we were ignoring before. And if you're not building your apps right, you're not building your apps right anyways. And you were just covering it for the fact that you're like, oh, we have a second latency between the database, that's good enough. That's still not correct in a distributed system sense. And now when you're talking about cross-country and the cloud, you actually have to build these sort of assumptions of how do you address these failure states right in your app in the first place. So I think some of the complexity is a little misstated in that it's just making you more aware of it by nature of the cloud itself.
Jesse, how do you respond to what is essentially collapsing previous, disconnected systems with distributed systems, or geographically disparate systems with modern distribution?
Yeah, I don't know. No, I mean, I think in reality, you are correct. If you think about how applications are written historically, there were multiple components to every application, and they were using a service catalog. That service catalog wasn't available on demand. That service catalog was set up once and ran forever. I mean, look at the history of managed hosting business. And my BizBlueBox started as a managed hosting company. You set these things up for a customer, and they ran, and then they needed a new service. We went and we created that service, and the customer utilized it. But we're doing that on a VM by VM basis. What we're doing here is transferring that now into an API call where you can get those pieces as you need them. And those pieces, theoretically, you don't have to think about healing them. You don't have to think about sort of the cow or puppy, pets, whatever you want to call it. You don't have to think about those pieces because the API is handling it for you. So in reality, the actual consumption and utilization of those services is pretty similar. The purchasing of that service and the way it's provisioned, I think, is what's actually changing.
So in terms of, to try to put a little bit of a bow on that, it feels as if there's a conversation about the evolution of APIs.
Oh, yes.
The
Let's
rise
talk
of
about APIs.
the rise of deploy-centric applications. I guess a question I'd ask is there much of a difference between writing a web-native application and writing a multi-cloud web-native application? And how does deploy-centrism and self-healing or kneeling apps make a difference and move fundamentally beyond the old days of geographically disparate systems to something that we could call modern and distributed?
Yes, Randy loves the topic, and I love to disagree, so this will be good.
All right, good.
I mean, it's pretty. I mean, I think it's pretty well baked at this time. There's been lots of discussion about this. You know, in the new cloud world, applications run around failures, right? Just like the internet was designed for. I mean, if you come at things from the risk mitigation, pet's point of view, then of course, you're gonna try to wring all the risk out of the system. The problem is that you can never wring all the risk out of the system. There's no way to have 100% uptime. There's no way to reduce all risk. So then your next immediate question, this is why this came out of the hyperscale guys, they get to such a size that they risk hardware failures. It's happening all the time, constantly. Shit's breaking all the time at Google, just nonstop. So they had to say, okay, when it breaks, what are we going to do about it? And this is why you see people like Netflix taking something like the circuit breaker pattern. The circuit breaker pattern takes a distributed application and it says component A talks to component B. If component A is talking to component B and at some point it starts seeing a high error rate or B goes away, it just backs off and stops trying to talk to B so that you get less of that cascading failure kind of effect. And what's funny about that is that's not a new pattern. Actually, the first time I saw that was in the mid-90s. Everybody who uses the internet uses a similar pattern indirectly through ISPs, all of which have something called BGP route flap dampening that occurs on the Cisco switches that they're running, or Juniper, whatever. And those that BGP route flap dampening does the same thing for routes on the internet. And so, when I think about IT, I think about it as never being. It's hard to come up with something completely new. I don't think of cloud as being new. It's a reconfiguration of stuff that we've done before, and we're trading off. We're moving from the land of risk mitigation into the land of it's going to fail. So how do we handle it, and what does that mean for the application layer? And I just don't think that that's really a debate. What are we debating?
We're debating APIs.
APIs are just a tool.
And they took it a step further to Chaos Monkey, which is one of my favorite pieces of software.
Yeah.
Assuming failure is such a constant that you actually replicate it and you bring down your own infrastructure constantly to make sure your system is redundant, that is what the modern cloud looks like. Not just the system will fail, but if we are not assuming failure and baking it in everywhere throughout the whole system, we're guaranteed to be down.
So I want to back up one step. So the panel is called Multi-Cloud Strategies, and I think if we look back at the history of cloud services, for a very long time, beginning in 2006 when Amazon was in private beta to arguably earlier this year or late last year, Amazon was the public cloud reference API. So everybody that wrote applications, I'm going to disagree with you, everybody that wrote applications, yes, it is still the reference, but there are challenges. So everybody that wrote applications said, I'm going to go talk to Amazon's API. And all the early cloud adopters hard-coded things to speak to this language. Sure, there were tools like Fog or libcloud or other abstraction engines that built a programming language agnostic interface to those cloud APIs, but by far and large, most people wrote to Amazon. Now you've got Google Cloud entering the mix. You've got Azure entering the mix from the public cloud perspective. You've got OpenStack, CloudStack. Now you've got Joyent shipping their product line entering the mix from the private cloud side. And the reality is that the API of the cloud itself, to me, no longer really matters. Applications are going to get written to an abstraction layer, and that abstraction layer needs to be able to speak to all these cloud services. The problem with Amazon and with customers that begin to adopt Amazon is that they've got a set of services that are compatible with every other cloud. It's basically storage and networking at its base layer. Excuse me, storage, compute, networking at its base layer. Then they've got the other 120 services, things like database cache and queuing, that all speak their own language. And there's no way to build a compatibility layer with RDS and something that runs on Google, or something that runs on Azure, or something that runs on OpenStack. And so what you see is this challenge. I'm looking forward to your response, but you see this challenge of how do you actually begin to adopt multiple clouds when every cloud is fundamentally different. If you back up one layer and you say, all right, can I build or use a set of technology that can speak to all these clouds? And there are plenty of technologies that exist. There's platform as a service technologies. There are abstraction engines that allow you to do this. And there are things like Chef or Puppet or Ansible configuration management tools that allow you to speak to the base underlying object, whether that's compute, storage, or networking. You use those to build your abstraction engine. That becomes your API. And from that, you then build your application on top. That, to me, gives you something that actually allows you to enable true multi-cloud utilization. So from our perspective, that technology of choice is something like Cloud Foundry from a platform as a service perspective. You write your applications to talk to a platform as a service such as Cloud Foundry. Cloud Foundry is written from origin to speak to all the primitives across all the cloud providers. It can talk to VMware on-premise. It could talk to Google. It could talk to Amazon. It could talk to OpenStack. And you let that technology manage all of the application and all of the service dependencies. And from that, you have a platform that actually lets you run a true multi-cloud strategy. That's where I think we're headed. That's the reality I think we're at today. Amazon has had the lead. Everybody else is catching up, and now we're beginning to, in my opinion, see that transformation.
Now, Randy,
Yeah,
I don't want to take away your opportunity to respond to that, but can I color it one bit? Because there's a question that came in from the audience about that I think speaks a little bit to the abstraction layer. And the question is, I'm deploying a large multi-cloud today for a big software company. For some users, we'd like to publish a single API that can abstract across VMware, AWS, OpenStack. What's the recommendation and the thought here? Does such a capability exist? And so
It does. I'll get to that at the end.
Okay.
So, with all due respect to Jesse, I mean, it's just utter nonsense. You know, one of the things here is that I'm not just an infrastructure guy, but I've also been an application developer guy, and I've supported SaaS applications, deployed them, maintained them, on Amazon and other places. And the thing is that I get this sort of weird rap that I'm like pimping the AWS APIs, which I'm not. I'm pimping the AWS architecture, which is actually very similar, or if not the same thing as the Google architecture. And at the last OpenStack Summit, I had a very, very detailed rundown on what I mean by hybrid cloud and what I mean by cloud interoperability. And the problem is that people get all tied around the APIs like, that's one of 6 elements that I define as being important. The other ones are like performance guarantees, SLAs, and availability and uptime, total cost of ownership, the behavioral compatibility, and so on. So I don't know if people remember, but there was something called IPsec in the 90s, still out there today, obviously, and people would build IPsec VPNs. And when IPsec came out, none of the VPN vendors were compatible with each other, even though they all had the same standard. Standards don't come from like protocols or software, things like that. They come from actually taking a system and modeling it and having testability around, is the system behave the way that we expect it to? And so that's what we need. And so you look at something like the idea of having an abstraction and it just hides the underlying cloud. What if Cloud A and Cloud B have 10x different performance? Right? Your abstraction isn't going to do shit for performance variations. It's not going to do shit for availability variations, right? Thank you, Josh. So the problem is that people get really confused. They're like, whoa, it's just infrastructure, and we're going to abstract it away, and we're going to have this magical platform as a service thing, and you just stick your apps on it. You never have to worry about it again. And that's like saying that like roads don't have to have standards and the same signage, and that railways don't have to have the same lines, and that carriers don't have to use the same protocols for your mobile phone to work. It's just not the way it works. Imagine this. You've got a whole bunch of electrical devices in front of you. Some of them take 3 volts DC, 12 volts DC, 9 volts DC, 120 volts AC, 208 AC, 50 hertz, 60 hertz, blah, 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 blah. Now go tell the power company that all of those things need to have their own native power delivered directly to them, right? The power company is now screwed. Their cost of delivery of power is now 10x. The reality is that we need a standardized system, a standardized platform, both for public and private cloud, that is the same fundamental infrastructure, that has the same performance guarantees, same SLA and availability guarantees, most of the same APIs, and the same behavioral compatibility, that we can test and show that private cloud and public cloud operate and behave in the same way. And then you can put the applications on them and move them around and get true application portability. But without that, it's just people sort of saying, oh, stick your application in Docker and it goes everywhere. No. That's not the way it works. That's not the way it works.
We're so far away from ever getting to that point. And yes, I agree that would be a nice.
We're not.
We are. That would be a nice thing to have. But in reality, if I go to Europe, I can take my power cord and I can plug it in. And there are transformer boxes that will allow me to take something that talks a different language and put it in the middle, and that will give me a compatible power source. And that is what I think we need today, whether it be Cloud Foundry or it be abstraction engines.
When I first started doing networking in the late 80s and then going into the early 90s, TCP/IP had not won. There were people who had just AppleTalk networks and other people who had IPX networks, and that shit just didn't work out, right? We had all these crazy gateways between them, and it was really messy. And what wound up happening is that TCP/IP won, and the idea that Amazon isn't driving a new standard, isn't the de facto standard, the gold bar or the bar that we set for everybody else. I mean, that's just crazy.
I agree. As day to day, I do not build infrastructure other than needed for the apps. We build apps, and the cloud is still somewhere in Virginia.
Hopefully you're running in 2 zones, though.
You would be surprised how often not. Like, it is still a trade-off. And for a lot of consumer apps, the downtime of EC2 East is good enough. So when I say somewhere in Virginia, I do mean all of the Amazon network, but sometimes it is literally just Virginia. That said, we are a long way from these abstractions we're talking about. There's a lot of magic and hand-waving going on about what will be in the future, but there's a big gap between the Heroku, which has this closest, hey, it's just abstracted computing and just push it up, till you're at the scale where you're building your own systems in EC2, and then it's not abstracted. No, I know what my data store is, I know what language it talks, how it performs, how it needs to be tuned. There are no data store abstractions that don't have trade-offs, whether you're using React or Postgres or some other worse choice.
Totally. And you look at Heroku, they can't even put it on another cloud.
Yeah.
I've talked to them before. They can't even move it.
And for application development, it's not like you have this magic compute and you have this magic storage. No, you have very specific things that are replicating what it was in the hardware world. We're a long way away from magic storage with no trade-offs.
So if you go back to the enterprise applications that we're talking about rewriting here, most of them aren't going to be the Netflix of the world. I think there are certain applications like Netflix that have a scale where writing to the native APIs makes sense. But the majority of enterprise applications that are being rewritten may have 3,000 or 5,000 enterprise users, or may have 30,000 users. And those types of applications can be written on top of something like Cloud Foundry and can be deployed multi-cloud today. It's not a fantasy. We've got customers doing this today.
No, that's not. There's no question that Cloud Foundry has a place, but Cloud Foundry is like Java Containers 2.0. If you went and you said, okay, we're going to redo WebLogic and WebSphere for multi-language, and we're going to do it in an environment where the underlying infrastructure they run on is dynamic and not static, voila, you have Cloud Foundry. But that only solves one set of problems. If you need a high level of custom, you're not going to run Netflix on Cloud Foundry, right?
Correct.
So there's a spectrum of solutions that you have here, from fully baked applications all the way down to do-it-yourself, Chef, Puppet, Ansible, so on, and everything in between. And Cloud Foundry fits one clean niche. There's no doubt about it, but it's not going to abstract everything.
Well, let's talk about the bulk of the workloads in the middle market and the enterprise market today that are being translated from legacy implementation to new architectures. The bulk of those applications, call it 80%, will be written in a way that they can sit on top of something like Cloud Foundry. I'm not saying Cloud Foundry is the solution. I'm saying that type of technology is the solution. These applications can reside there, they will reside there, and that will provide the support for multi-cloud capabilities.
Oh, so you mean Heroku?
I mean Heroku, but I mean Heroku that has the capability to run. The customer we've got today, they run dev test on Amazon. They run production on OpenStack on Blue Box Cloud. They've got the capability, if Blue Box Cloud doesn't have a region, they've got the capability to go and put it on top of another Amazon region for production, or to put it on a Google region for production. It's that level of abstraction that they can say, I can write my application to one API, and that API is a software stack that has compatibility across a globally distributed set of different compute engines. That's the power of multi-cloud, and that's the power of platform as a service.
So if I can interject a question here.
No questions.
You guys have been doing fine. I'm not going to get in the way of good material. This question of not only having a set of reference APIs and reference architectures, but performance guarantees and availability guarantees. I had a conversation just before the panel started with Tim about the ease of Heroku push and the elegance and fundamentally, when we talk about multi-cloud, I think organizations are throwing down their credit cards. They're going into public cloud. Now, most organizations have a de facto multi-cloud problem, or maybe not problem, a reality. And that's driven by this fundamental desire to be more agile, be more efficient, deploy now.
No, that's being driven by IT not being able to deliver on the engineer's requirements.
Right, how's
Engineer-
that disconnected? That's the same thing, right?
Yeah, no,
It's
They have that
Technical
need,
ability.
Same
they
side
hit that
of the coin.
roadblock.
keep going.
They have that roadblock, and therefore they are finding ways to work around it. And so, in the context of agility, where Heroku push and coming standardization around Cloud Foundry, I would assert that Cloud Foundry and Heroku and deploying an application into a scalable runtime container decreases the friction with dev, and therefore is the wave of the future for everything that doesn't need some other sort of tuning. Is it fair or unfair to characterize infrastructure as a service, whether it's public or private, as being the last bastion of really strong performance guarantees and control that IT operations can bring?
How many people think that in the next 10 years, most enterprises will still be running Microsoft Exchange behind their firewall? No takers? All right. So behind the firewall. So I think the reality of the situation is that when you look at somebody like Amazon or Heroku, that they can deliver a service, a cloud-based service with a higher level of uptime and a much lower total cost of ownership. Or you look at a Salesforce.com or something like that. And the reality is if you look at the vast bulk of enterprise applications today, most of them are not mission critical. Most of them don't provide competitive advantage. And as you go through that triage process and you say, is this something that we outsource and get from a SaaS player? Is this something that we need to, re-architect and move to private or public cloud and so on? I think a lot of those start to go away. There's no doubt that enterprise platform as a service has a place for utility applications and that there will be many of those. But if you ask somebody who's trying to do something brand new, like, for example, Hyatt's just hired 100 cloud-native application developers, and they've got a whole DevOps program and boot camp that they're putting these guys through. You think those guys are working on utility apps? No, those guys are going to be working on stuff that's providing competitive advantage to Hyatt to help them get to the next level, to help them become now a technology business more in the hospitality business. And then those kinds of applications are very frequently not going to fit in a highly abstracted environment because you have to do something different, almost by definition. I don't know what that is, but say transcoding. Some people need specific GPUs that their transcoding is tied to. There are just ways in which, for the apps that matter, which are going to be the ones that are interesting, that you're going to do yourself, that you're going to take on your business, you're going to have to figure out how to cloud nativize them, to do that Netflixification process, right? Otherwise, those apps should just get outsourced.
But I want to talk about the boring applications. There's $475 billion spent on IT annually, right? And engineering started...
Why are you still maintaining those boring
Engineering
applications?
started the process of cloud adoption. It's now being handed over into the budgets in the hands of IT operators. And they've got to deal with this amalgamation of crap. And that crap doesn't need to run in a high-performance environment. It needs a abstracted environment that can run dev test wherever they want it, wherever it's cheapest. And it can run production wherever it will be most performant from a latency perspective. There will always be those really cool cutting-edge applications, the Netflix.
Yeah, but why in the future would you run any of those apps? Why would you run any of your support desk software like Remedy when you can go to Zendesk? Why would you do that? I mean, your Remedy has absolutely no competitive advantage to you, right? Like everybody in the early days of SAP, everybody would spend hundreds of millions of dollars to customize their SAP deployment, and then they realized it was asinine, so they changed their business models to basically do what SAP did, so it wasn't so expensive to do the deployment. It's the same kind of thing, right? If you've got, these boring apps, you got to have a pretty great justification for keeping them in-house.
Which is why you go from 340 monotonous line of business applications down to 120 that need a compatibility engine between where they're going to run.
Well, then per you, they just got cut by 2/3.
They did.
I'd like to point out that...
But that's where the bulk of the cost and the revenue for companies exists today.
As a side note, even your counterexample is already on the cloud and done. There are transcoding services. And
Yeah.
this is where slice and mount services, even if you have this app that has that one unique thing, well, that one part gets done differently.
No, my point was that if it was a mission-critical competitive advantage for your business, you're doing transcoding as a service, you've written code that uses a specific NVIDIA processor to allow you to do transcoding 2 or 3 times faster, that you might do that.
Even that, you would spin it out separately and then sell it to everyone else, potentially. Well,
No.
unless it's very core to
Kaiser
your business.
Permanente still runs their electronic healthcare records on a mainframe. They spend $100 million a year for that. They're not going to change it. You know why? Because it works. They don't want to mess with it, and it's their core mission-critical competitive advantage. They'll be running on mainframe 20 years
Yeah,
from now.
it works, and they don't want to mess with it, though, is baked into so many of these companies, not just for that core one. I don't think these companies are always so good at that evaluation of this is not core and we can afford to ship that out. I agree with your premise. I don't know if all of the companies you're talking about understand or agree with your premise.
Yeah.
We've got a whole new generation of application engineers, though, that are coming into these organizations with an entirely different frame of reference, right? And they're replacing the engineers today that are sitting there managing this old COBOL or Java application, ripping their hair, and the new guys are ripping their hair out, saying, what are we doing, right? And that will be the beginning of the transformation to take those boring things and either rip and replace with something that's off the shelf or re-architect it in a way that actually is competitively advantage, provides a competitive advantage to the organization. We're just at the beginning of that process right now.
So, yeah, in a decade we can start then when they're seniors.
Let me switch gears just a little bit.
Yeah.
Randy,
When do they bring the sumo suits?
we'll do that soon.
Okay.
Randy, you've written previously, and I think that maybe you would all agree, that the shift to AWS for most companies isn't fundamentally about cost, it's about flexibility. And so a general question then is, how should organizations and companies think about total cost of ownership in a completely elastic or a mostly elastic new world? And while we're busy thinking about technology and TCO around infrastructure and apps, is there a parallel to be made between flexibility and cost with employees and talent?
So it's a broad question to ask about TCO and cloud, but what I find interesting is that, historically what we had is we had the data center, and there was a big black box, and we would shovel money in one side, and we'd extract value out the other side, and we don't really know what happens inside. And one of the potential advantages of moving to a cloud model, whether it's private or public, is that there's an actual direct correlation to an application that's deployed and how much resources it's using. And you can actually measure that in near real time so that you can find out whether an application is justified, whether you can get an ROI back on it. And that's a huge value because we're moving towards this world where things are accelerating. You want to get more apps out sooner, and you want to see if they actually take off. And if they don't, you want to be able to kill it. I mean, how many enterprise data centers have you seen where you walk in, you say, what's that stack of hardware back there doing? And somebody's like, I don't know. Who knows? Kaiser, again, I don't mean to pick on them. When I was first talking to them, the new enterprise architect told me that he had gone around their West Covina data center, which was built at 25 watts a square foot, that they still have in production, which is incredibly inefficient, from the 80s. And he came around the corner, and there was a row of VAX 11 750s that were powered on, doing something, nobody knows what. I mean, VAX 11 750s, man, in 2009, I mean, that is crazy.
They're mining Bitcoin.
So
Yeah.
I think cloud allows us to actually measure TCO and to figure out ROI, both the infrastructure and application layer, and that's absolutely critical to understanding how we're doing and measuring ourselves for success, which I think is a part of the DevOps mentality. And I hope I answered most of your question there.
Tim?
I would compare, okay, so you have a slightly higher cost, say, for processor hour. How's that TCO measure against your entire industry being disrupted when you didn't shift something in your company going out of business? Like, the stifling innovation and not moving to cloud and not being able to move forward has such a greater risk that if you're just focusing on, oh, hey, it costs us a little more per processor hour, and you don't adapt to this coming world, when these people are 10 years into their field, you're going to get your lunch eaten. And any TCO cost that doesn't factor in what the greater costs are out your organization of what next big thing you're stifling is a cost is a
Opportunity
horrible
cost.
Yeah, it's a giant opportunity cost.
So do you see, in terms of cloud adoption, do you see companies sitting down and doing this, saying, it takes me, every time I need to touch this thing, every time I need to deploy a new test dev instance, it takes me X weeks. This represents flexibility that I'm being crushed.
No, we have a customer that went, they onboard their clients, and it was taking them 3 weeks, the legacy way of doing it. They have a data center, and they're running all their things manually there. They bought a hybrid cloud, so they run all the database, load balancing, egress IP in their data center. They run application compute in our data center, cross-connected and true hybrid. They went from 3 weeks to 3 days, and of that 3 days, more than 2.5 of that is spent in legal contracting the account, and the rest of it is sort of a push button deploy, and then they've got full accounting of the cost of each one of those clients on the system. I mean, that's the type of transformation that we're seeing.
And similar to Randy, I say it's the difference between scale and scalability. Of scale is sort of a fixed, I have all this hardware and I'm running at massive scale. But the cloud is not necessarily about any given scale. It's about scalability. It's about not having to over-provision your hardware ahead of time. So if you're smart about how you build it, your TCO isn't actually that awful, and that I can have a system that can scale orders of magnitude without waiting for provisioning hardware. That allows me to build much more flexible systems and actually at a lower cost if I'm looking at, I may have millions of users for this app. But right now, do I really need to keep provisioning hardware for rapid growth to stay ahead of that?
So now we can measure the infrastructure. We can measure CPU cycles per transaction and things like this. We know what our aggregate cost for an application is running in the cloud. How do organizations need to think about measurement of their development and ops organizations to fit a new model of flexibility over cost?
That's a good question. You take it first, Tim. I need time to think.
So measurement of development and ops, as in delivery of features, as in velocity, like this dovetails with agile, like which direction are we heading this question?
Well, it's a question about TCO, and the answers so far have been pretty narrowly constrained to infrastructure, traditional infrastructure versus cloud. How can we sort of measure the total cost of ownership, the improvements in flexibility? And I think we've all probably seen some resistance to cloud, maybe resistance to DevOps movements within organizations. And I think that there's a reasonable parallel to be made here. What's the cloud of people?
Yeah, well, the cloud of people is contracting. That's the obvious comparison.
From the contractor.
Yeah, if you buy enough fixed hardware for what you know your fixed cost is, and then
Tim, do you have an API endpoint for that?
I do have an API
perfect.
endpoint for that. It's my phone. Call me and I'll help you scale up your team. That's the obvious parallel there. But I think there are more interesting points around if you can cut that staff down. There is dev and ops, when we're talking cloud, are not separate. Like ops and operations, system administrators are slightly different, but if we're talking the people that can build real systems, systems engineers are developers too, and there are a limited pool of talent you have. What if you could free up 30% of your smartest developers who are right now maintaining stuff to build new cool things? What sort of payoff is that provided by building new systems?
Your company does this. This is your life's work, right? Or at least to date. And how would you like to be measured as someone in the development and operation space in terms of the flexibility versus cost that you bring to an organization?
We look a lot more at user-facing, and this was one of your later questions about what are the other things from web-scale businesses that enterprises aren't doing, and this is service to the user, that all of this is infrastructure masturbation if at the end of the day we're not actually delivering
That's
trademark. Yeah, that's a good
yeah,
line.
that we're not building apps that serve the user. So you're not sitting there, you don't have, when you're in an enterprise app, you have a captive audience and you say, you use this billing system, this is the billing system you have to use. That doesn't work in the consumer space. If your invoicing system, the one I use is Harvest, it's the best of the worst. But it's still better than anything I used before. If it wasn't better than everything else, I would move on to anything else. So we build apps, we do user studies, we do UX, we pair design and development. We're trying to build apps that actually make the world a better place for the users. And this sort of service to your end user thinking could be applied a lot more to the enterprise. And I think it is one of the harder approaches. If you're used to, we have a very defined, constrained system that we're going to build to an exact spec instead of how could we actually make our users' lives better? That's one of, I think, the harder cultural shifts to bring to the enterprise.
So I guess if I'm going to say, how do you measure it? I'd say, my flip answer is it's about time to value. But if you kind of try to break that down and unpack it, it would be time to get an MVP done, time to change the application, and then site uptime or availability. And those are the three things But I think if everybody's on the same mission together, it forces the DevOps mentality. I always, when I like to talk about a story about DevOps, I always bring up Amazon, right? Because Chris Brown, who was the lead developer on EC2, who sits on my advisory board, he told me the story of the early days, and Amazon was trying to scale up, and they had thousands of products or services already, and they couldn't train the operators on them. There just wasn't enough time, and the operators couldn't come up to speed on all of them. So that's when they did that shift, and they said, you developers are responsible for the uptime of your individual product. And they had the operators build a common set of tools that all those guys had to consume. And I just think that kind of rethink of sort of the methodologies is driven largely by how quickly can we get a new product out, how quickly can we make changes to existing products, and how do we make sure the site is up all the time.
Yeah, yes. I mean, it's about velocity. It's about time to value. How is an enterprise where I have a set number of developers and I have a set number of applications, do I increase my throughput? And what technologies and processes can I use to actually implement that? But I think your description was spot on.
In development, we have the measure of agile velocity, which is number of story points per project. Those sort of metrics, I'd be a little sketchy about applying across teams.
Yeah.
But what I would say is, can your company right now deliver a new app in 6 weeks or 6 months, or does it take 18 months? Like 6 months is a long time in the consumer space. If you're not at the point that in 6 weeks you can have something tested in people's hands and being iterated on, then until you get to that point, you don't even know what you're missing. That it's hard to compare apples and oranges when you're talking orders of magnitude of what you're measuring here. So, yeah.
Well, I'm getting a very clear indication that it's about 7 o'clock, and I see a hand.
I just have a quick question. I'm pretty new to this industry, and I see a theme, and it's being kind of repeated a little bit here. I was wondering if there's any major voice that is against velocity being the primary selling point, so to speak. Is there any maybe pushback to that? I mean, you say 6 months, like it's a long time. I just started my career, like that's going to be nothing in 5 years, right? So, just kind of curious about that.
So if I were to repeat the question, the question is are we building a straw man out of?
Is there any entity that is the voice for maybe the fastest isn't necessarily?
Is there a voice?
I mean,
Is there a voice for a more moderate, a more reasonable, moderate speed in approach?
There are a lot of individual voices. I don't know one single entity, but plenty of people push back from the agile, focus on the next week's worth of design. You're leaving things on the table. The issue I have is anytime you're not actually measuring something, which in my view is user-studied experiences, then you're building what you think you need. If you spend 18 months building what you think you need and you're not delivering something into users' hands and verifying your assumptions, I very much believe in what Lean talks about here. It's not any given time, it's that how soon can I start verifying my assumptions. At a software design level, that's a much greater debate of how much do you build and iterate on designs versus it's hard problems where you go in a room and think about it. That, at the end of the day, though, we are building software for humans that are not us. So if we base it entirely upon our assumptions, I know we're getting something wrong. So how quickly can we tighten that feedback loop up?
So there's not a single voice, but the faction that tends to want to dig in their heels most is the information security teams and the compliance teams. And the reason is that rapid rates of change scare them because the current tooling around security and compliance is not designed for that rapid rate of change. And there's a great book called Security Engineering by Ross Anderson, which I consider to be the best security book ever written. And he basically points out how a bunch of security systems, physical and digital, were subverted. And every time they were subverted because the set of assumptions that they were riding on top of changed out from underneath them. And so rate of change actually makes it difficult for you to evaluate whether those assumptions have started to shift or not because the change is happening constantly. On the other hand, the value to that rate of change is so high that businesses are driving over the top of security. 3 weeks ago, I was in New York City for a roundtable panel with a bunch of financial services guys, and they were all talking about velocity and speed of change and DevOps and moving faster as an organization, and there were like 3 security people there who were just like freaking out because they didn't want to see that. And so I just, I did security for a long time, and it's important, but we have to start rethinking security in cloud. Josh?
Is there a correlation between the fear of the rate of change and the cost of failure in present tense, right? So the cost of failure has dramatically begun to drop as we can control and contain failure much more quickly than we used to be able to. No?
Yeah, I have been saying, and this freaks people out, but that we want to fail faster inside the enterprise now. I mean, startups are used to that mentality. Enterprises are like failure because the penalty of failure is very, very high in the enterprise. If you do a big initiative and it takes 18 months and millions of dollars, and it could mess with your career. But if that initiative is 2 weeks and costs $10,000, then we've brought the risk down. Now the problem is that there's a lot of risk associated with security and PII kind of data that is very hard to measure and somewhat subjective, and we don't have clean ways to sort of factor that in.
What's the software failure rate for projects? 60%? I don't remember. It's some ridiculous number, like 60% of all software projects fail. That's partly by how we're defining them, by these big giant initiatives that can't adapt. I would say slow-moving software projects that have to meet a very specific spec within a given time are akin to trying to dock with the space station by turning all your steering thrusters off and hitting go. You're like, we have to be exactly right there. And of course you fail at that. The sooner you can deliver and adapt the system you're building, the more you can redefine that failure way to be just a hypothesis failed that then you adapted to.
Yeah, I've been going back to the security thing. Sorry, Jess, I don't know if you were going to jump in, but I have this thing in my head, and I haven't done a blog post on it yet, but when I was dealing with those FinServ guys, I realized that their mentality of this is going to be a terrible analogy, but their mentality of security was like a fortress, right? You build a big fortress. And how many people saw Pacific Rim? I hope you saw it. You have the idea of mechs and stuff. I think security needs to move to that model where the security is more like an envelope that's attached to the app that follows it around. It's more like a moving fortress, a mech or something like that. I know it's a terrible analogy, but you have to get out of that static, moats and gates kind of, mentality.
The Maginot Line.
Yeah.
Right. The Maginot Line is not a good model of security, and it's our current model. If anyone's been watching the OpenSSL rebuild, the current state of security is so horrifyingly bad that holding that up as, oh, what about security? It's like, yeah, what about security? Exactly. That at this point, we do have to move forward and figure out how to move forward more intelligently on security, because a lot of this tooling is fundamentally broken at so many levels it terrifies me that we continue to use it.
Huge opportunity.
So I think we're opening this up at this point to questions from the audience. One thing I would like to ask is if there's an extra microphone floating around that it's
Your front table.
that it's made available to people so that we can hear you
It's a secondary
on the
microphone
broadcast.
availability zone.
Come again?
So I heard about the faster rate of releasing products from 6 months to 6 weeks, like you mentioned. So in this new world, how would you define quality of a product? Is that definition changing? And in the cloud world, how would you define it? Because all about speed, speed, speed. But what about quality? How would you go about defining it?
It's about rate of adoption, right? A quality product is adopted amongst the user base that exists, and whether that's an application enterprise where there's 4,000 users and you've got everybody actually using it, or it's a consumer product and you've got a hyperscale trajectory growth. Quality product adopts people who begin to use and maintain their use of a product.
I mean, at what point the consumer may think that it just keeps on changing on them, maybe 1 time, 2 times, 3 times. Is there any benchmarks have come out where they say, you got to get it right after 2 or 3 times? Because like you mentioned, failures are going to happen, right? So deal with it. But how about the consumer side?
Well, maybe can we ask a question in reverse here? And presumably you have standard methods of assessing quality within an application today.
That's right.
And why do those methods fall down in the context of more rapid delivery?
That's right. So in this cloud world, what's the new definition of quality, I would say? Yeah.
I'll also ask, what software are you using that is good and doesn't have bugs and isn't broken? Because I want in your world.
I don't think the quality metrics for an application have shifted significantly. They're all the same, right? It's about bugs and features and all that good stuff. But the thing that's maybe a little bit different is that a lot of these new initiatives, they're around dealing with data and trying to transform it and make it more useful. They're about plugging into social platforms. They're about, talking to mobile devices and mobile applications. And so almost all of them are related to uptime. And so I think one of the quality metrics does have to start to be that combined responsibility for, having the service available, for some amount of time, which is probably the biggest shift that I see.
And something we didn't talk about much because we didn't get those questions. All of this, just say monitoring 15 times through everything we've said. Like that is sort of a baked-in assumption to all of this, that you're monitoring your uptime, you're monitoring your responses, you're monitoring what users do. This sort of monitoring is a thread that has to tie all these things together so you can actually make informed decisions. Yes.
Yeah,
Josh, you gotta
absolutely.
get
It's
up.
the OODA loop, right? It's the observe, orient, decide, act. I mean, if you don't know what's going on with your service or system, you can't actually do anything to maintain it.
Yeah, I want to pull on the thread from the last gentleman around quality. Doesn't the concept of a minimum viable product, by definition, reduce the quality of an
No.
application or solution?
No. Minimum viable product means that you're doing the minimal set of features necessary to actually test the idea. If you're doing anything more that allows you to have poor quality, then you have a problem. You're going to do the bare minimum set of features, and that features are going to be at a reasonable level of quality for you to assess whether it's whether the customer is going to be happy with that solution.
There's something different between minimal crappy product and minimal viable
Yeah.
product. Like, it has to work.
And
So
also-
who decides what's viable, I guess, is the question.
That's a very good question. I think if
No,
you
the
take your
community
MVP out
does.
to the customers that you're making it for and they piss on it, then you didn't hit your target.
Well, maybe this is an opportunity to interject a bit of discussion about deploy-centric models, cloud-native applications, and the opportunities for testing not only applications but the infrastructure that they were designed to run on concurrently.
I just want to make a quick comment there. So I think, again, we're living in this new world, right? Legacy applications, you wrote something, and then AOL burned it to a disk and shipped it to the user, and they tried to install it. And if it didn't work, like, they've just now burned 400 million CDs. What are they going to do with those, right? Now we're in a world where I can deploy a web application, and if it doesn't work, I can fix it within 30 minutes and redeploy something new. And that real-time reality of being able to iterate on applications to get feedback from the users, from the error rates, et cetera, that's totally changing the way you architect applications. And it's that type of implementation, that type of deployment that really makes that notion of minimum viable product actually work in this world.
Yeah, you see
also
people-
think it's important if you're borrowing from Lean to also talk about the hypothesis. Like the MVP is only part of it. What makes it your MVP is, are you testing your hypothesis on this software is what people need? And that helps you really define what is minimal, what's viable, what's enough
Goes back to monitoring.
Yeah, what tests that, what is enough to test that hypothesis?
Yeah, and people take it to a further stage. Somebody like Google is actually testing hypotheses all the time. They'll add a new feature, and then they'll measure, to how 10% of the customer base responds to it. They'll even do A/B testing like you would with a website, but around application features. Is it better if we put the button up here or down here, and then see whether customers click on it and then respond to that? And the only way to have that type feedback loop is to have that kind of more agile, more kind of rapid development cycle model.
As does Facebook with your psychological well-being.
Yes.
Just curious, guys, what are you seeing on the bleeding edge of architectural reference architecture is kind of the most recent and interesting insect you've seen out there in terms of the cloud architectures? Good example is the reference kind of, are people making direct connect work, keeping data on-prem? How are they doing that? What's the next evolution in kind of iterating beyond direct connect data locally, compute in the cloud? Where do you see things going, and what's the kind of cutting edge, bleeding edge cool stuff you've seen recently?
Yeah, I can answer that. So I think direct connect is a cool concept. Again, the challenge there is proximity. And so in order to really be able to harness the power of the data that exists on premise, you need low latency to those scenarios. And with 14 data centers, if you're lucky and you have your existing data store within 3 milliseconds or less of that direct connect endpoint, you're great. But Seattle's a great example, right? The direct connect in Seattle goes to Oregon, and it's 11 milliseconds of latency between the Oregon availability zone on Amazon and anything I put here in Seattle. For most modern web applications, I can't write something that will support 11 milliseconds of latency and do that in real time. So I think the next generation of technology we'll begin to see goes back to proximity. How do I get a cloud set of technology, which means self-service a self-service service catalog available to my users with the proximity of something that may exist on premise. That's something that we're approaching at Blue Box. There's a couple other companies in the space that are working on that as well. And I think that will fundamentally shift the way cloud technologies, particularly private cloud technologies, are adopted within middle market and enterprise buyers.
So I want to disagree with that, but I'm not going to take a whole lot of time. Latency is absolutely an issue, but if you're not architecting your app to deal with it, then I'm going to say something bad again. You got your head up your ass. I mean, the problem is that the days of I've got 0 milliseconds latency, infinite bandwidth, the storage is always up with infinite IOPS. That shit's gone because it never worked. Right, so your app has to do that. Now, granted, there are apps, that are going to be problematic with 11 milliseconds of latency, but there's lots that aren't. And, and that's where I'll leave that. But you asked about, kind of new architectures. I mean, I think one thing that's really fascinating is sort of the move to Flash, because if you look at some of the problems that people are trying to solve, they get a lot easier when going to Flash. And it's not just the IOPS exactly themselves, but it's the move away from SAN-based architectures to direct attached storage. You go and you look at Netflix, they did their performance tests on Cassandra using, a columnar database, key value kind of store. And they scaled it out perfectly horizontally from 50 to 150 to 300 servers. They got perfect linear throughput with triple writes on Amazon Web Services with 300 servers. And then they went and took that and they put it on 11 SSD-based instances. Bam, 300 to 11. Now, that just blows my mind. Why would you have a SAN, right? Because you're never going to get the performance out of a SAN over the network that you're going to get from a flash array over a PCI bus. It's just never going to happen. And if you're already doing the data replication, which should be part of an app routing around failures, if you're already doing that at the application layer like Hadoop does, then why do you need all of this other redundancy? I just don't think you do. I think you just simplify things, and that way you also get a better failure model. I mean, when SANs blow up, I'm sure we've all seen this, it's just not a pretty picture.
So I want to piggyback on that real quick. I think one of the most interesting things that's come out in the last couple of months, Rackspace announced a product called OnMetal at Structure a couple weeks ago. And OnMetal, there's 3 compute types. It's a bare metal as a service, so you buy by the hour, there's an API. But one of the compute types is a flash-based storage array. And it provides 200,000 IOPS billed by the hour. So if you look at the cost per IOP of that particular infrastructure, it blows everything else in the marketplace away. And the pricing, it's not publicly released yet, but if you contact their sales team, they'll send it to you. It's unbelievable. So that type of technology, combined with what Randy was talking about, I think will fundamentally change the way people think about storage.
Yeah, take that Oracle rack cluster and throw it in the garbage, get MySQL on a couple of boxes and go to town.
Your turn.
Actually, on a related note, for all we've talked about cloud, it is really addictive sometimes to I've worked with Blue Box when we've needed some super high performance, and it was easier to throw dedicated hardware at it because they do provide cloud and dedicated in the same space. And that's sort of like what Rackspace is giving you there in that direction. Sometimes it's very nice just to run directly on a Fusion drive for your database and then have the cloud for the app scaling. So there occasionally are more flexible, different hybrid cloud, entirely different model, which is old school dedicated hardware mixed with app cloud.
Scale up is a legitimate approach, yeah. And I don't think we're saying, I've never said scale up's going away. It's just that scale out's now the default and scale up's the exception instead of the other way around.
Yeah, we're entering a marketplace now where scale up no longer needs to mean dedicated hardware. You've got Rackspace, you've got SoftLayer, you've got CenturyLink. All these companies are bringing, you've got bare metal servers, they're the original. You've got all these companies now bringing bare metal as a service to market over the next couple of years, and that gives you the advantages of that bare metal performance and gives you the advantages of hourly based billing and availability on demand. I think that combination by itself will be hugely transformative over the next couple of years.
Good. Maybe one more question.
Thank you. This is a multi-cloud management panel discussion. I heard a lot of ideas, good things, bad things. I like very much about Jesse's point about writing an app for multi-cloud, basically, right? So there are a number of things that we need to worry about when we are writing an app to multi-cloud. Other than Jesse's idea of writing to one set of APIs, are there anything that you would advise an app developer to focus on. When they want to migrate applications, federate applications from one cloud to another, are you going to say no, just write to one cloud, and that's what you got to live with?
Tim, what is your experience on this?
Write to your current requirements as cleanly as you can. So write to one cloud if that's what you're building now. Write good, clean service boundaries so you can abstract different things away to different clouds. Don't make your life that much harder if it's a theoretical, oh, I might run it on a different cloud at a different point. If you have a real need right now for some reason where like this might run on different storage engines, and then sure, you build it in. But I have rarely seen people really need an individual piece to be abstracted that highly to entirely different places to put it. It is usually more horizontal or slicing of different services that might run in different places. So is it multi-cloud if I put all my files on S3 and run on a different database provider, or is it only multi-cloud if my files all live in multiple different cloud providers?
So I have a flip answer, but I'm not going to give you that one. I think the keys are when you're building for an environment, don't use any of the higher order services that could be dangerous. So for example, if Netflix had used SimpleDB and DynamoDB on AWS, they would have locked themselves into that system. So you want to use just the core infrastructure services that are reproducible anywhere. That's number one. Number two, you're going to build around some kind of framework, Cloud Foundry, Chef, Puppet. You're going to have something that deploys and manages the application. And you're going to put that in a continuous integration system. Well, it's in your best interest to try to run that against multiple clouds. Even though your primary might be AWS, you might want to target Google as well so that you know that the application can be deployed there on a regular basis, even through all the versions. So you've always got the option of cutting from Amazon over to Google. Third, I personally think, I remember the days when I was working in ISPs in the early 90s, and every enterprise at that time got a single internet connection from a single internet service provider. Nobody does that anymore. But at that time, that was how they all started. And then they'd have a problem with that service provider, and that became a de facto standard. And every enterprise now has 2 hardware vendors for a given platform. So I think it really behooves you to be running your application on both Amazon and Google, or Amazon and Azure, or whatever, one of the big 3. And then to make sure that it works in both those places. And the thing is like, I disagree with Jesse that you can have this abstraction that works everywhere, but I do think you can get an abstraction, whether it's Cloud Foundry or something else that you know and have tested works the same on Amazon and Google, or Google and Azure, or Azure and Amazon. Maybe not 20 different clouds, but one of the major ones, 2 of the 3 major ones. And that's all I think it really matters.
Could I emphasize one point real quick? Continuous integration and continuous deployment, everything must be heavily tested, unit tested and integration tested. You must have it tested backwards and forwards. When I said well built, that was a basic assumption. If your app isn't thoroughly well designed and tested, you're going to have a nightmare of not knowing what runs how when you move it around.
I just want to say, I think that this industry in particular has a tendency, this industry being sort of modern web applications, has a tendency to architect for complexity versus simplicity. Right? So we see customers all the time who are like, I wrote Tinder for cats, and it uses 48 different services like MongoDB and Hadoop and MySQL, and I have 5 users, right? And they come to us with it architected that way from day one. And I think it's that over thinking of the actual architecture of the application that causes a lot of people problems. So if you can start with a very simplistic approach, use that MVP type deployment methodology, build and test the application, get it up and running, and then grow as it goes. Google didn't start architecting their applications and their infrastructure the way they're doing it today. They learned that over the last 15 years, right? We didn't architect our technology the same way over the last 15 years. So start with simplicity, get something built and working, and grow with it as your business and your idea evolves.
It's a general engineering problem, though, right? Because what I've seen is every engineer wants to build a starship.
Right, because it's awesome.
Whether it's web or anything else, right? I mean, they're just like, oh my God. And it's dangerous. That's why the smaller, rapid iteration cycles allow you to course correct. You don't want to figure out in 6 months that you just You
don't build Facebook by setting out to build Facebook, because that would take infinite amounts of money and you wouldn't get there.
And infinite amounts of time. Yeah.
So I would propose that we take this to the post panel party. For those of you who haven't yet enjoyed some of the things that were provided by some of our sponsors, Georgetown Brewery brought some beer, Three Howls Distillery, but would especially like to thank the three panelists here. Thank you guys very much for coming. I've appreciated the discussion. And I think, yeah, my mic is still on. Thank you for Flip on TV for helping make this live streaming available. Jason?
And also to Synapse at Level 11, we couldn't have done this without them. We hope that we can continue to do it here. Our goal is going to be to continue the conversation online. So if you guys could, any questions that weren't asked, we'd love to be able to answer those online. So just thank you guys very much. Come grab me if you're interested and learn a little bit more about NWTA. We're converting into a social purpose corporation, so we're looking for board members right now, and we're really interested in hearing maybe what additional panelists you guys might like me to go get. Hopefully they don't take a year and a half to get. Thank you guys.
Thank you all for coming.